Between 2013 and 2015, the size of data created was larger than the size of data existing from the birth of the internet. Analyzing this data has become our biggest concern, seeing as the data is usually too large for humans to interpret. We decompose these large matrices of data into formats that computers can understand. We will now talk about the methods of data decomposition on two dataset examples: an informative dataset on the prices of Bitcoin during 2000 days, and a movie to user rating dataset acquired from Netflix. The first method of data decomposition is singular value decomposition, or SVD. This method factorizes any large real matrix X into three matrices, U, S, and V transpose. The orthonormal matrices U and V retain the data from the original matrix and can be considered as scale projections of the real data.
Moving on to the second technique of decomposition, which is QR decomposition. QR decomposition converts the original matrix into two matrices. The first matrix Q is obtained by getting the orthonormal basis of the column vectors of the original matrix. This is done by using Gram-Schmidt's technique. The second matrix is calculated by substituting the matrix Q into the equation and solving for the matrix R. Principal component analysis, or in other words, PCA, is one of the most popular linear dimension reductions. Usually, it is used as a standalone technique and sometimes as a starting solution for other dimension reduction methods. PCA depends mainly on projecting the original data into a set of orthogonal axes. As shown, it applies diagonalization process to the original matrix to be the product between the following: Q, which is the eigenvectors matrix, lambda, which is the eigenvalues matrix, and Q transpose.
And now we will discuss the QR decomposition technique. This technique depends on three matrices. The first matrix is C, which depends on the number of columns in the data. U is the middle matrix, and R is a matrix which depends on the number of rows of the data.